All right. So first of all, thank you guys for sticking around. I'm sure it was a long day with a lot of good info that you guys saw today. How were the sessions so far? Thumbs up. Let the records show. Thumbs are up. So as we said, my name is Stevan Beara. I'm a part of the Solutions Architecture team in AWS. If you were expecting anything else but data migrations talk, you're in the wrong room. So this is your chance. All right. As I mentioned, we'll be talking primarily about data migration. What that means is that although AWS has a lot more services than this when it comes to migrations, such as workload migration or database migration, we will not be covering them today. We will also cover a little bit about storage, but again, that will not be the star of today. Today we'll primarily speak about services you can use to migrate your data from on-premises into the cloud. And just so you're aware, for the most part, if not for all the part, you can use these very same services, if you so choose, to migrate from AWS back to on-prem. So we don't lock you into AWS. If you choose to leave, you can use the same tools to go back. Of course, we hope you choose not to. On the right of the screen, as I mentioned, these are the storage services. On the left of the screen, these are the data migration services. It's a subset of the tools that we have. And even though I presented on a similar topic in Ottawa about a year and a half ago, I don't know if any of the people were at AWS Innovate Ottawa 2017. I would doubt. I think, oh, no. It was about 1/6 of number of people that are here today. So in 18 months, we are having over 6x people come to learn more about AWS services in Ottawa, which is really, really exciting for us. I live in Ottawa, so seeing this kind of interest is really encouraging. So thank you for being here. Even though there's a lot of new services, some of these services here may appear familiar, right? So if you look at Amazon Glacier, it's been around for a while in AWS. But even so, about a couple of months ago, we announced general availability of Amazon Glacier Deep Archive. And this is a class of storage where if you're looking to move your data in for a long-term retention, where you'll be accessing it once, twice, or less a year, it is incredibly cost-effective, right? So if you think of Amazon Glacier, you're looking about $0.25 cents per gigabyte, or about $4 a terabyte per month. All numbers are US. If you look at Amazon Glacier Deep Archive in Montreal, it'll set you back $1.8 per terabyte, which is 60% less. And this just came out about a month or 2 months ago. In terms of the tools that we use to migrate data, key takeaway here is that you can think of them through 3 different lenses, right? So you have your online transfer tools. Usually we use these when the amount of downtime you want to keep to the minimum, right? So you have an application, it's running all the time, your RTO is quite small, you don't have time to shut it down for a weekend and do things like that. You will start looking at online data transfer tools. Offline data transfer, it's in situations where you have a limited network or a huge amount of data and you're comfortable with either stopping your workload for a while or using these tools to feed the data into AWS, which you will then follow up with syncing using the online data transfer tools to reduce that downtime. And finally, we have hybrid storage that our customers use to run workloads both on-prem and AWS simultaneously for most part. So why do you want to do this, right? Why are you moving the data to AWS? Even though each person and each company and each department has their own reasons, initially people were moving into AWS primarily for cost effectiveness, business agility, operational resilience, as a DR view, and so on. What we're seeing more and more is that people are starting to move into cloud for innovation, right? The tools which are available to you on premises are typically build your own tools, right? So even if you look at attempt to the private cloud, usually those are limited to IaaS type services, storage, networking, and compute. Where once you move to the cloud, you have a plethora of services available to you. You have AI ML tools, you have your analytics, you have your IoT tools. So there's a lot of people who are starting to move the data into the cloud, not so much to save money or operational resilience, but actually to do more with their data, right? So the fact that you're now able to leverage over 165 services that we offer today really makes a powerful story for our customers. But moving the data into the cloud doesn't come without a certain amount of challenges, right? So you're looking at your potentially workload disruption. You're looking at how quickly can I move it there? What's my cost of moving it there? And so on. So when you're really moving data to the cloud, and really when you're moving data anywhere, not just the cloud, you have to think about 5 things, right? The first one you have to think about is, what is the type of data that I'm moving into the cloud? And this seems like a really, really simple question. I would say this is the most difficult question. So in my previous life, I spent 17 years dealing with data and migrations and so on. And in all my projects, the longest part really was understanding where is my data, what is my data, what workloads is my data affecting, right? So when you start looking at moving the data to the cloud, that is the very first question you need to be able to answer. The next question you have to answer is it going to be a one-time move? So am I moving my workload into the cloud one time and that's it? Or is it a continuous movement? A good example of continuous movement is IoT devices sending data into the cloud, or people performing backups or DR into the cloud continuously, right? The third one is this going to be a one-way to the cloud, or is it going to be bi-directional, right? Fourth one is, how much data and time do you have? I touched on earlier when it comes to the offline data transfer. Often we will want to move the data through the network, but we have too much data, or we have too little time. So this next fifth one kind of ties into that. What is my network capability into the cloud? So we'll start off talking about AWS Direct Connect. So AWS Direct Connect service is really an alternative to using internet to connect your environment with ours. Right? It's a dedicated pipe from your environment into AWS, which is typically faster. It doesn't have to be, but it should always be more reliable. So currently we have 4 Direct Connect locations in Canada. 2 are in Montreal, one's in Toronto, and one's in Vancouver. And there's different reasons people use them. For example, a very popular reason why people use a Direct Connect location in Vancouver is to ensure the compliance with FOIPA. I'm not sure if there's any people from British Columbia in the audience, but that requirement is basically to transfer PII data, not only to store it only in Canada, but the entire path of the data from the premise to the cloud has to be in Canada. Obviously, if you're doing that through the internet, there's no way to guarantee how that'll get routed, right? If you do it through the Direct Connect, you know that you'll be compliant with that requirement. A very interesting reason some people use Direct Connect is to reduce their cost. Although there's obviously a connect to the service, for the service, there is a reduced egress fees that you're paying. So this is typically done by a very, very, very large AWS users who are egressing a huge amount of data, and that's one of the reasons. Consistent network performance is another reason. Even though you might have let's say a 10 gig pipe going into the internet, internet is not guaranteed, right? Meaning that there could be congestion, and not so much are you going to have that 10 gig bandwidth in terms of are you going to be congesting against somebody, but what is your latency and what is your packet loss, right? So packet loss is a huge, huge enemy of bandwidth. So it doesn't matter if you have a 100 meg, a gig, 10 gig link, if your latency is 80 millisecond round trip and you have 0.1%, so 1/10 of 1% packet loss, that single TCP connection went from 1 gig, if you have 1 gig, to 4.6 meg. The packet loss is a huge enemy of bandwidth, as well as latency. Another interesting thing about Direct Connect is that it's connected to all our services, right? So every time you provision a link, and the bandwidth of Direct Connect that you can choose varies from 50 megabits all the way to 10 gigabits. If you choose between 50 megabits and 500 megabits, you would be getting that service from our partners. Or you can get a dedicated link, still through our partners, but to AWS, either 1 gig or a 10 gig, which now you are able to divvy up into 50 VIFs. So you have 50 virtual interfaces, either into our private endpoints or public endpoints with a single dedicated connection. So speaking of moving data from your on-premises into AWS online, this is a very new service. It was announced at reInvent 2018, so 6 months ago. And it's not available in Canada yet at this point, but the reason we made it is that we heard a lot of customers asking for an online service that will transfer data from on-premises into AWS. Currently, why people would want to do that is usually they have workloads which are running that they cannot turn off, right? They have to do it while they're running. It's an active application data. My RTO is too low. I need something like that. Another reason people are using these kind of services to do online transfer is when they're transferring a huge amount of data and they need to do something with it in the cloud before they ship a result back. And a very common thing we're seeing here is in research. So for example, genomics. They're able to transfer terabytes, if not petabytes of data. And then what they're able to do with that data, instead of using their on-prem systems where they have a limited resources to crunch them, actually there's a department here in Ottawa which is using high-performance computing for this very purpose. They're able to not wait a year to get a result. They're able to get a result in days, sometimes hours, right? So what they do then in the cloud is they spin up a huge number of clusters, they analyze the data, and then they ship back that result. And that really is saving them time. And in case of research, very often this type of results are saving lives, right? So from the time you're looking to get an answer, you're reducing it 300x. That's pretty powerful. And then finally, a lot of people are also using this service to do DR and business continuity. So people will say, so what, right? I can use rsync. Nothing wrong with that. It's an open source tool. It's free with my Linux. Or I can go in COTS and get it. The purpose of this tool was to be specifically the highest throughput with the lowest latency and to be integrated with AWS services as a whole, right? So it gives you fast data transfers, it's easy to use, it's secure and reliable. And really what we're trying to do is combine that open source capability with the speed of AWS. So when we talk about speed, and I touched on the fact that just because you have a 10 gig pipe doesn't mean you're getting a 10 gig performance. The way this tool was designed, we actually use a proprietary transport protocol we create ourselves, then we put an envelope of TLS around it. But with every single agent that you deploy on site, and I'll talk a bit more about what those agents are, you're able to run 10 gig network into the cloud, which is pretty impressive. That was our main goal of this service, to make sure that we get a really solid performance, right? The next thing we want to do is to make sure that this data management service is completely integrated with all kinds of different management tools. So I don't know how many people in the crowd are familiar with CloudTrail or CloudWatch, which are our management solutions. It's fully compatible with those. And then we validate all the data that's being sent, right? So every time the data is being sent from the source to the destination, not only do we validate it in flight when we're sending it, we also validate it, if you so choose, it's an option, once the data lands in AWS. So you can be 100% sure that the data that you had in the source is the same as the data you have in AWS. And the price is, even though it's not available in Canada, in all the regions it's available right now, it's 4 cents a gig. So how do you go about doing it? That was another goal we're trying to get, is to make it as simple as possible. So today it runs only in VMware. So you would put in your ESXi environment. You see what are the requirements. One thing you'll notice with the requirements is we don't talk much about what disk requirements there are. And the reason why we don't talk about this agent, what disk requirements they are, it requires very little. Your data is either in flight or in memory. We don't store any data on that agent. It's literally used as a proxy device to move it. After you deployed your agent in AWS, that's it. From that point on, it's managed through AWS console. It's being patched by us. There's very, very little work for you to do. At that point, you will decide what is my target, right? I will first mount the NFS to that agent, and then where am I sending the data to? Am I sending it to S3 or am I sending it to EFS? Now, if you're choosing to use this tool to move data from the cloud back to on-premises, it's just the opposite, right? My source is going to be either EFS or S3, and my destination is going to be my NFS server on-premises. And that's all left to do is to start the task. As mentioned, you have your NAS system on your site. You have your DataSync agent, which is, for all intents and purposes, a VM, as we discussed. There is a proprietary protocol within the TLS, and then that's it. You don't have to worry about spinning up any EC2 instances in the cloud. Everything is being managed through this service. One of the common patterns we're seeing, even though it's pretty early into the service, is where people are using this tool to reduce the amount of storage on-prem. And people have different reasons. Either they're running out of storage, or they just want to reduce the physical footprint or electrical or cooling footprint in their data center. So they have a NAS system today. They connect it to the DataSync agent. They transfer the data into S3 bucket, and then they introduce a storage gateway, a service that we'll cover at more length in a little while. But once they do that, they're able to use a file gateway to natively access the data in that S3 bucket. So their servers on-prem are able to access data which is S3 through the same protocols they were accessing their NAS server through, and all of those files look the same. Both data is the same and the metadata is the same. To the server, for all intents and purposes, the data has not moved. So you may have been wondering why there is, you're in the cloud conference, there's a physical device on the stage. This is a Snowball Edge. I don't know how many of you people have seen it in the past. It's something we'll talk about next. So a lot of our customers, as I touched before, they either have a lot of data, they have a small bandwidth or high latency, so they're not able to move data from on-prem into AWS online, so they choose to do it through using devices like this. In the past, what you would do is let's say you're stranded in the sea, you're on the ship, and you're running a research, right? You have a bunch of systems on the ship. You might have 5, 10, 20 USB drives in those systems, collecting data, waiting to send them to the cloud to do more analytics. And then you would get back from that ship, you would mail those systems and hope that those drives survived, right? So show of hands, how many people here have heard of SneakerNet? It's nothing new. It's been a couple people in the crowd have heard of SneakerNet. And basically, okay, how many people in the crowd have heard never underestimate a bandwidth of a UPS or a FedEx truck, right? So similar idea, right? What some people don't know that the first instance of that quote was, I think, never underestimate the bandwidth of a station wagon. And actually, the first instance was in 1971. So almost half a century ago, there were people out there saying, you're able to ship a huge amounts of data using a truck or a car or something like that. So there's a term SneakerNet, there's a term TrainNet, and there's a term PigeonNet. And the PigeonNet is pretty funny because in April Fool's in 1990, one of the people submitted an RFC 1149. And actually, the title of that is IPOAC, and it stands for IP over Avian Carrier. So basically, they said, I'm going to take a pigeon, I'm going to strap some USB sticks on it, or whatever the time they were able to strap on it, and I'm going to send it. Obviously, it was an April Fool's joke, but people took it seriously. There was a lot of people, not seriously, but people were commenting on the RFC, and they had fun with it. So in that spirit, with AWS, what we did is we took inspiration from that, right? So we said, there's a couple of things that are going to happen. When you're shipping those drives, they can get damaged, right? So whatever we create in order for you to take the data and ship it has to be sturdy. And actually, it's so sturdy that I'm not a little guy, but this thing is about 50 pounds. And it comes to you, and it has the address over here. So you never have to talk to anyone. I think the beauty of Amazon is that, in general, AWS or Amazon.com, is if you truly don't want to talk to people, you don't have to, right? So you go on the console, you order one of these, it gets shipped to your work or wherever you specified, and you get it, right? And then what's the problem when you have these kind of devices? You were on the, like I mentioned, on the sea for a long time, and you did a lot of research, and things break, right? And that sucks. So what we decided to do is make a device that not only doesn't break, it flies. Right? You heard about drones in Amazon? Oh, it doesn't fly. It was supposed to fly. It doesn't fly. We have to work on that. But what we made sure is that when that kind of stuff happens, I don't know how many people here have seen videos of things being dropped off in their house or at work. This is not strange. This kind of stuff happens all the time. And if your data is on that thing, you want to make sure it's still on that thing when that thing happens, right? Because if it's not, I was just at sea for 8 weeks, I worked on my research, and now my data is gone, right? So when we created this device, we made sure a couple of things. Let's talk about references. 2 years ago, I had a similar talk to today. I ordered one of these devices, UPS driver came to my house, and this is a quote from him. So if you don't take it from me, take it from a UPS driver, right? So September 19, 2017, the weirdest thing happened, right? So I was on vacation, I had to present today. Last week, it was Thursday, I realized I never ordered one of these. I went on my console, I ordered this, and I'm really hoping it gets in time, right? I really wanted to do this. I wanted to throw one in front of you guys. It came on Monday, which was exciting because I was at home. I was able to get it. Same guy, delivered one of these guys, and he's in the picture there. Now this is a picture from 2017, not from Monday. It was cloudy, or I think it was raining. But he came to my door and said, I was really hoping I would get one of these guys again. I'm like, are you the same guy who delivered? He's, yeah. But anyways, I find it funny, so I'm telling you this story. Nothing absolutely to do with the capabilities of the box. But when we talk about the box, it really comes in 3 flavors, right? So you have AWS Snowball. It actually comes in 50 and 80 terabytes. There's really no reason to get 50. That was our first generation. It's purely storage device. Snowball Edge, which this is storage optimized Snowball Edge, is a 100 terabyte flavor. I think about 92 terabytes is usable. And then we also have a compute optimized Snowball Edge, which I'll talk about in a second. Both of these types of solutions come with 8.5G hard shells. And as you can tell, it's quite important, right? They're rain and dust resistant. Please, you notice I did not have a pool here. I didn't throw in the pool. Doesn't mean they're waterproof. They're just resistant, so don't test it. Come to think of it, don't go around throwing them, right? When you order them, do not throw them around, just because I did that. This is on camera too, which is good. And the compute-optimized Snowballs, actually, they came out with a GPU version. So if you have a workload that you don't have any internet connectivity, you might be in a mine, oil field, or in Northwest Territories, and you happen to have no connectivity, but you still want to do work on that data you're collecting, the compute-optimized Snowball Edge is a great solution. And if any of you in the audience is looking to move 100 petabytes, actually we'll do as little as 10 petabytes or more, in the 2017 reInvent, we announced the Snowmobile. All of these products are actually Canadian made, hence the snow thing. They are designed in Canada. And that's a 45-foot tractor trailer that can hold 100 petabytes in the back. So let me know, and more importantly, let our account manager know if you're interested in this kind of solution, because they'd love to talk to you about this. So how does Snowball Edge compute optimized and storage optimized compare? So storage optimized was the first type of a Snowball Edge we had. It comes with 100 terabytes of usable storage, as I mentioned. Compute optimized has a bit less, but what compute optimized has is a lot more SSD space for your workloads, right? It has a lot more CPU, it has more RAM. It is just more geared towards running workloads on-prem. And typical job lifetime, we have customers who are doing these 3-year reserved instance type of purchases, right? They'll buy them, they'll keep them for a year, 2 years, 3 years, because they are living and doing their job in the place where there's no internet connectivity. They have no way of pushing it back to us until it's ready to go. So in terms of the benefits, a couple of things I want to point out is that I showed you one device. These devices cluster, right? So we're able to put between 5 and 10 of these devices into a cluster. Primarily, the benefit is a more reliable storage, as well as we have ability to lose up to 2 nodes and your data still intact in that cluster, right? One thing I should mention, once I send this data back, they put into my S3 bucket. What we do with those Snowball devices, we use a NIST 800-88 process for cleaning them. So when we ship it back to the next customer, all the data is gone. And each unit is completely wiped before being sent to the next customer. The process of ordering is quite simple. Like I mentioned, you go into your console, you choose the type of a Snowball device you want. It's relatively cheap. I think Snowball 80 terabytes is $250 US to be shipped to you. Snowball Edge storage is, I think, 300. Pro tip, forget, in my opinion, people might disagree with me, forget the Snowball and always get Snowball Edge storage optimized. Not only do you get more storage, it's a lot easier to transfer data between your environment and that device. Without it, you'll need a separate S3 adapter controller. It's much easier to deal with Snowball Edge. One thing I forgot to mention, the protocols we use on it is quite standard. You can use NFS or S3 protocol. If time is of essence, if performance is of essence, you will want to use the S3 protocol. We still have NFS, but the performance is much better with the multi-upload S3. So more importantly than just making sure data is available is making sure the data that you put on the Snowball device and the data that gets to you, that gets to us that we're putting into the cloud is the same, right? You want to make sure that nobody has tampered with the device. So the way we ensure that is multifold. So underneath, I don't know if you can see on the screen, the red rectangle. If somebody tries to pry open the box, those tabs break, and we will be aware that somebody was tampering them. We also use custom one-way screws that we make that are non-standard. So it's pretty difficult to unscrew once they even break those tabs and try to get into it. And even if they do that, what we have is a TPM chips on that box. So if anybody was messing with the OS or firmware kernel of the box, it won't even boot up. So at any type of tampering, we destroy the box, we send you a new one free of charge to make sure that once the data ends up in your S3 bucket, is the same data that you ship to us. In the Snowball Edge Compute optimized box, we go even further, right? So we actually have the NFC chips integrated into the box. You're able to use Android or iPhone. I checked yesterday, the Canadian Apple Store does not have it yet. I'm not sure about Android, but you're able to scan those NFC chips and see for any signs of tampering yourself. How many in the audience still use FTP or SFTP in their work, home, etc.? This is way less than I thought it would be, about 1/10. That means that 90% of you are lying. It's incredible. Every customer I go to, almost every customer I go to, SFTP, the protocol that was created in 1997, last time ratified in 2006, is still one of the most prolific protocols in the use today. It's unbelievable. Everywhere we go to, we go to the customers and go, you know, just use S3, right? But the problem with the S3 is that not every application speaks S3. So SFTP is very simple to use, and actually it was one of the biggest asks from our customers that they wanted to see in AWS. They said, why don't you guys have a managed SFTP service, right? And we're thinking to ourselves, we're a cloud company, we're progressive, but at the end of the day, we do what our customers ask us to do, right? So, as we mentioned, SFTP is quite ubiquitous. Now you're thinking, well, who needs a service, right? Like, what's wrong? I can just either, today, I have my server, I put in the SFTP, either a open source or I put in a COTS solution for an SFTP server. I'm running it on my server. Things are fine. I don't need this. Who needs this, right? One of the interesting things is that, I don't know about you guys, patching of things is not that exciting. A lot of people don't do it or don't do it fast enough. Just for giggles, you guys can Google SFTP CVE, right? Just Google SFTP CVE. You will get 92,300 results. And this is not to say there's 92,300 CVE or vulnerabilities in the SFTP solutions, but just to say there's quite a few, right? So even if you're very diligent in patching, how quickly are you able to patch once you find out? And more often than not, those vulnerabilities have been there 3 to 5 years before you found out about them. On-prem solution also, with the SFTP service or your own servers, once you download things, typically they stay on a single site, so data is vulnerable. The management of the server, right? Like very rarely do you have auto-scaling on-prem. At least I don't know of any of my customers who have implemented auto-scaling successfully on-prem. So either the server is sitting there doing nothing, or that server is not big enough, or the pipe is not big enough to collect all that data, right? Either students are registering all at the same time, or people are submitting taxes all at the same time, but it's difficult to scale things which are on-prem. And actually, another reason why we put this in is people tell us, yeah, we need FFTP. We say, what do you need FFTP for? Just put in S3. And I said, our application doesn't work with S3. And we're like, oh, that's easy. Just change your application. How hard is that? You know, just a couple of lines of code. And no, not too many people want to do that. So by creating our own service, what that gave our clients is the ability to place the data into S3. For people who are not familiar with S3 storage, it is a highly durable storage. It's 11/9 durability. It means that if you put 10 million objects into S3, you can expect to lose one of those 10 million objects once every 10,000 years. We replicate it across three sites or 3 availability zones for people who know what those things are. And we have multiple copies. So it's a highly, highly durable solution. A lot of people want to place data into S3, not just as a final location there, but also to act on it, to do analytics, maybe replicate that data to another region, and so on. And the SFTP service is integrated with all the AWS services you would expect, right? So all the logging is done through CloudWatch. CloudTrail is making sure there's no funny business going on. And the way you actually do it is very, very simple. I don't know if you noticed from my slides in DataSync and now here, we will have maximum 3 steps apparently, right? If we have a 4-step, we just don't want to have that service. So you map your host name. Most people already have the SFTP service. with their hostname that their customers are using. You can take the hostname, bring it to AWS. If you are using user keys, you can also import those, so there's no need for your users to revalidate this is what they're trying to connect to. So they wouldn't even know any change has occurred. You would select which S3 bucket you would want to place the data in, and that's it, right? You either set up your own users or you use your existing identity providers with the SFTP. So when all is said and done, what you have is the same users you had before, using the very same clients they were using before. You would have our service. Again, there's no EC2 instances to spin up. It's a fully managed service. And you have your S3 bucket. So earlier today, I mentioned a storage gateway family when I was discussing DataSync. So the storage gateway family is very interesting because what it enables you to do is to still use your instances or your servers on premises with the data which is residing in the cloud at the local speeds and local latencies, right? So how does it do that? Well, we have three different options. One of them is a file gateway. The file gateway is the only of the three options here that will take your data and preserve it completely, right? So if you're writing a file, stevan.doc, or docx now, I guess, into the file gateway, and you peek into the S3 bucket, you will see that object in S3 bucket. So it's a one-to-one relationship, and you access it through the NFS protocol or SMB protocol. Same what you're doing today. Volume gateway, there are two flavors I'll talk about in seconds, but it behaves like block storage, right? So you access it through iSCSI, it writes data into AWS. You have two options. You either have a stored or a cached mode. I'll talk about it in a second. And finally, for you guys that are still using tapes to do backups or archive data instead, you're able to use tape gateway, right? You can think of it as a VTL of sorts. So it'll pretend it'll show up as a robotics, it'll show up as tape drives, and then you're able to use it with your backup software typically. So why do people like this? First of all, it's a standard storage protocols, right? You heard me say NFS, SMB, or people still refer to it as SIFs, even though it's much different. You use iSCSI for both block and for VTL. The cache in the devices is fully managed. What we're doing is we are keeping just enough data, just enough of the working set that you guys are working with, so to a user, the latency is local, right? Even though the storage is actually sitting in AWS. We also have optimized data transfer. If you write a file and most of the file already exists in the file gateway, they'll just send the block changes into AWS. Similarly, when you're pulling the data back, they'll do a sub-file block level pulls into your on-prem. And they'll do also multi-part upload or download, so they'll increase the performance of it. And just like all of the other services I mentioned, it's fully integrated with the other AWS solutions. So the cool thing about the file gateway, as I mentioned, it keeps your data intact, right? So if you do want to use Athena, or if you want to use our Redshift or Select or many other tools that we have today, you're able to use that right into the S3 bucket, right? So the files look exactly the same. They haven't changed at all. So you're able to search through them, you're able to run queries, and so on. In case of the volume gateway, as I mentioned, it behaves like a block storage, meaning that if you were able to look into that S3 bucket in AWS, which you can because we're the ones managing it for you, you wouldn't be able to see anything. What we do is we optimize that movement. We compress it, we ship multi-part uploads. It's just ones and zeros in a compressed format. But to your application server, it still looks like block storage. It still looks like their iSCSI LUN that they were used to getting. In case of a cached mode, we keep as little as you want, meaning that it's up to you how much cache you put into the storage gateway. So you're able to have a petabyte volume in the cloud, so you could literally write a petabyte into S3 and have as little as 150 gigs on-prem. Unless you have a very small working set, I wouldn't advise that, because obviously, if you're constantly processing data which is not on-prem, you'll constantly keep making calls into AWS, increasing the latency and frustrating your users. So try to identify what is your working set, multiply it by 10, 20%, that's how big your cache should be for a cached volume. In case of a stored volume, relationship is a 1-to-1, right? So if you have a 50 terabyte volume that you're working on, it's going to be 50 terabytes in that volume gateway you need to provision to. And you're also going to have 50 terabytes in AWS Cloud. So there's always, latency is 100% of the time local. You'll never go and fetch something out of AWS because it's not local. But the benefit is you're never going to have the latency, but you'll need to provide the storage. And finally, tape gateway. This is pretty cool because a lot of our customers have compliance needs, right? So either it's medical data or tax data or some other kind of data that I have to keep for 7 years, 20 years, death of a customer plus 7 years, like hundreds of years. So you're able to write data into the tape gateway. It ships it into S3, and then you're able to move the data out of the library, right? And what that really means when you move the data out of the library, you're actually moving data from S3 into Glacier, or you're moving it from S3 into Glacier Deep Archive. So I don't know if you guys remember from the beginning of the talk, I mentioned there's a very, very low cost service. It's fully integrated with the VTL tape gateway. It comes in a few flavors. Either on premises, you can have a virtual machine, VMware or Hyper-V. You are also able to get a hardware appliance. Or if you want to run this in AWS, what some people are doing is they're running Storage Gateway on-prem. Their data is in AWS, and they're using AWS as their disaster recovery. So in case of a failure of the primary site, they spin one up in EC2, and now they have all their data running in AWS. It's a very low cost because you don't have to have it running in AWS until the moment you need it. And that's why we have it as an EC2 option. So we touched a couple of times into network and latencies and pipelines and so on. What happens when you have users around the world, right? They're trying to access your data in Canada. Well, their latency is going to suck, right? And the cost of running a direct connect across the world is also quite high, so maybe not recommended. So what do you do in that situation? We have this service called S3 Transfer Acceleration. And what it does is identify the closest POP to your users. So regardless of where they're in the world, we have 180 POPs around the world, points of presence. And it'll identify the closest point of presence to that user, and it'll ship the data from the user into S3 or vice versa through Amazon Global Network, right? So it'll use our backbone to move data from the user into AWS or vice versa. And this is done really, really simply. Basically, typical bucket name is bucket name.s3.amazonaws.com or bucket name s3 region.amazonaws.com. And what you do is you go and you click this box, you want to enable it, and you change the destination that your users are looking to instead of saying s3.amazonaws, s3-accelerate. That's it. This is not even a 3-step process, this is a 2-step process. And what your users are left with is better performance of either reading the things from S3 or putting things into S3. So this one is not that Canadian friendly, I guess. We did some testing. We had a bucket in Singapore, and we had a number of different cities where we tried to upload data into that bucket, right? So if you notice here that if you're already in Singapore and you're trying to upload the data into the Singapore region, what will happen is it'll go and find the first point of presence and then move it to Singapore region, which is going to take longer than it would have been without it, right? So not very good idea. If all of your users are in Montreal or Ottawa, then this feature will, and you're using our Canada Central region, this feature will not be of that much interest. But as you start moving away from that bucket and your users are becoming further and further away, the benefit of S3 transfer acceleration really shows, right? All the way to the point where you look at the user in Rio de Janeiro is able to get 171% improvement over what they were able to do without this feature. Until today, every single service I talked to you guys about was AWS native service. But there's more options than just AWS when you're looking to migrate your data from your on-premises into AWS. We have a slew of partners that have spent a lot of time, money, and know-how in things they've been doing forever, right? Like you can look at a company like Commvault, they've been in backup business for decades, right? And you're able to use them, which is also integrated with our products to move your data from from your on-premise into AWS or vice versa. So you're wondering, like, why would I want to do that, right? It might cost me more or so on. Often these tools will have functionality we don't have, right? So if you look at a number of these tools will have not just compression I talked about, but they'll have data deduplication, right? They'll enable you to automatically schedule when your backups are going to take place. They'll be able to catalog them. They'll be able to index them, things that we might not do today, right? So I encourage all of you to take a look at these different tools. And another interesting use for the partner tools is that even if you are using or considering using one of these partners on premises, and in the past, the only way to do that would be to order one and spend tens of thousands of dollars and hope it works. Now you're actually able to spin it up, as an example, NetApp Storage Controller in our AWS cloud, test out the functionality, see if it does if it meets your needs and your requirements, and know exactly what you're getting into. But there are a number of different APM partners that worked really hard and have a very solid solutions, and I encourage you guys to check them out. And that's it. I want to thank you guys all for coming. The last session of the day, you made it. You sat through, most of you anyways. There's somebody very excited in the back. I have one last piece of homework for everyone here. Please, please, please. I'd like you to complete the session survey. Only good things to say, please. No, I'm just kidding. Please provide both positive and constructive criticism. We take this data very, very seriously. We use it to make sure that the future sessions are up to your liking, improve what didn't work, provide more with what worked, and so on. So I just want to thank you guys.